This video is about the central pipeline systems or the medical gas supply. Please mind my voice, I have cold. Uh, this central pipeline system was actually made to deliver gases from a certain place from where it is stored to the delivery place, that is the operation theater. So the gases which are usually a part of central pipeline system is oxygen, nitrous, air, carbon dioxide, nitrogen, and vacuum is also a part, which is not a gas, but vacuum delivery to the operation theater is also a part of central pipeline system. Now it has three components. The first one being the source, second is the pipeline itself, and the third one is the terminal units which is present in the operation theater. So the source is the central manifold. This manifold term is used for a group of cylinders or group of storage devices which look something like this. These large cylinders that you can see on the left side and the right side. This is one known as left bank and right bank. Right. So these large cylinders are known as the central manifold. Now from this central manifold, there arises the labeled and color coded pipelines. These pipelines are going to deliver the gases till the terminal units. Now at the terminal point, it has self-sealing non-interchangeable sockets. This you must have seen in operation theaters that a pipeline is usually connected to a structure which is present on the wall of the operation theater, and then from that structure the pipeline is connected to the anesthesia machine. So these are known as the self-sealing mechanisms or the sockets. These self-sealing non-interchangeable sockets can be categorized into three types, which is DIS, NIST, and NIQC. Now DIS means diameter index safety system, NIST means non-interchangeable screw thread, and NIQC is non-interchangeable quick couplers. Now how do they actually look? This you must have seen that on the anesthesia machine, this is the body which has a small bore and a large bore on it, and it has certain threads similar to a lock and key mechanism. On the pipeline there is a nut and stem. This nut and stem also has thread corresponding to the threads of the body which is present on the anesthesia machine, and this body has bore, small bore and large bore, whereas the pipeline has small and large shoulders on it. So this is going to fit inside that particular body. Now why is it important? So that the corresponding body or the corresponding segment of a particular agent, whether it is vacuum, air, nitrous or oxygen, which is present on the machine is corresponding to the particular pipeline. So we cannot interchange or we cannot replace it. This is a type of safety mechanism. Now this is diameter index safety system. The second thing that we read is NIST, non-interchangeable screw thread. They are very similar to the DIS, but they are present on the British machines, whereas this is present in the American machines. Now usually in RML hospital we have Drager machines which are American machines, so they have this, but if they are British machines then they may also have NIST connectors. The third thing we said, before the third thing, this NIST has a check valve. This is actually a unidirectional valve, so the gas can only travel through the pipeline to the machine and not from the machine to the pipeline. This is a safety mechanism again in the NIST. Third thing was quick couplers. They are also known as Schrader valves. This is again the representation for the NIST. This is the anesthesia machine. We can see the cylinder which is connected to the machine through the diameter index safety system, and this this pipeline which is connected to the machine through the diameter index safety system. Sorry, I actually said for cylinder it is actually pin index safety system. So mind that thing, please. Uh, Once we are done with the central manifold, which consists of the cylinders, the large cylinders, the pipelines which are labeled and color coded, and the terminal units which we have read, that is this NIST and NIQC. But there's something which you need to remember, that this central manifold has cylinders. Now these cylinders consist of only gases. So this is one type of source for oxygen. But there are other storage devices like vacuum insulated evaporator or the oxygen concentrators. They can actually store oxygen in liquid form, and that liquid oxygen, which is stored at much lower temperatures, several hundreds of negative pressure temperatures, that is minus 170 to minus 180 degrees centigrade. So then they are warmed and converted into gas and then delivered through pipelines again. So it is not only the cylinder manifold from where we can get the gases. It may be through the liquid oxygen storage devices. When we come on to the liquid oxygen, it is a vacuum insulated evaporator, and it has quantity of 1500 liters. The temperature is minus 170 to minus 170 degree, which is much less than the critical temperature. Critical temperature of oxygen is minus 118.6 degrees centigrade. This is something that you should remember for oxygen forever. For pressure, it is 10.5 bar pressure in the liquid oxygen tanks, and then the liquid oxygen is warmed by a copper tubing. Once it is warmed to 15 degrees centigrade and it is depressurized to atmospheric pressure, this liquid oxygen can actually give 842 times of the gas. So you can see that how a small amount of liquid oxygen can produce such a large amount of gas, which is very economical for us. The problem with liquid oxygen tanks is that if you leave the tank as such, so the tank is going to gain heat from the surrounding. Now once it gains heat, the temperature will increase, and you should know that if the temperature increases, the gas will expand. Now this gas expansion will lead to increase in the pressure of the gas in the tank. Now this increase in the pressure will lead to opening of the safety relief valve, and that safety relief valve opening will lead to oxygen wastage to the atmosphere. So that is the problem, that if you do not have a large demand in a particular center for oxygen, storing the liquid oxygen can actually lead to a lot of wastage. One more fact is this insulated chamber is known as divars. All right. This liquid oxygen is actually the process by which it is separating the gases by utilizing the property of boiling point is the fractional distillation. This is how liquid oxygen is produced. Let me show you the diagram. This is how a liquid oxygen tank looks. These are large containers, and if you look at the diagram, you can see this is the vacuum containing vacuum insulated evaporator, and the temperature is minus 160 degrees centigrade. Now it has a safety valve, there is a pressure regulator. Now if the pressure this particular gas, sorry, the liquid gas, this has to be heated by a superheater, which is a copper coil usually, and then again a pressure regulator is used to regulate the pressure at which it will be delivered, the gas will be delivered to the pipeline. Now this will be the pressure of the pipeline. You should all remember that the pipeline pressures are always higher than the cylinder pressure that we put behind the anesthesia machine, so that preferably even if you open the cylinder, the pipeline gases are used preferably. It is usually 55 to 60 of Hg in the pipeline, whereas it is less than 50 in the cylinders. This was about the liquid oxygen. Now the last of this topic is oxygen concentrators. Now I'll let you see the image. These are the oxygen concentrators, and this again is present in RML hospital. Now the principle behind this oxygen concentrator is pressure swing adsorption systems. That means this there's differential adsorption of substances, impurities from the air, so that whatever is left is pure oxygen. What happens is air is entrapped into this machine. Then after the air is entrapped, its pressure is increased to 137 kilopascal. Now once it is done, the absorption material zeolite is used, which is hydrated aluminium silicate. This will retain the nitrogen and other unwanted material in the air, and that is how the oxygen is purified up to 95% by volume. One disadvantage is we cannot remove argon from this oxygen concentrator. They have an advantage that they have a lifespan of 20,000 hours, which is approximately 10 years. So you just have to change filters every 10 years and it will work. And that is how it is much more economical as compared to liquid oxygen, provided the demand is not that much, because it can only deliver 0.5 to 5 liter per minute of oxygen if it is a low flow concentrator, and if they are high flow oxygen concentrators, that can deliver 10 liter per minute of oxygen. This was about the oxygen concentrators. This diagram you can again see that they are zeolite towers which purify the gas. The last of this sequence in the pipeline system is the suction apparatus. This machine generates a negative pressure of 500 mm of Hg. Now this is the maximum pressure it can generate. Now after this, there is a controller which can control this pressure generated, and there will be a receiver in the OT that you usually see on the wall. It is then connected via a tubing to a nozzle, which is the Yankauer suction apparatus. And the principle used to create this suction is Venturi principle. In anesthesia particularly, there are various gas laws. One of them is the Venturi principle. So there are multiple applications of Venturi principle in anesthesia. One of them is suction. Obviously, very obvious use of Venturi principle in anesthesia is the Venturi mask itself. So this was all about the central pipeline systems. We'll talk about cylinders in the next video.